Tonight we're going to graph the derivative of a function. It's going to look very nice. It's going to be very visual for us. We start with the line, horizontal line, y equals 3. We know that the slope of a horizontal line is 0. So the derivative of this right here is just a horizontal line right at 0. Next one right here, we have a beautiful linear, a positive slope. Now you know, we hear the word derivative and slope often. We can start at any point and see, okay, look, up 2 over 1. Look, there we go, up 2 over 1 again. The slope at any spot here, since it's linear, is 2. We didn't have to even use the counting method because it told us the slope was 2. So right at y equals 2, draw a nice horizontal line. Now we're getting a little more exciting here. We have y equals x squared. So the first thing you want to pick up on right here, right at the vertex, there's a slope of 0, this point right there. So you're going to put a dot right at 0. Now from 0 on, this graph is increasing. This graph anywhere on here would have positive slopes. So this slopes, this is a very small slope right here, maybe like 1/2. This one up here, much bigger. I'm sorry, you can't see. This right there in that section, small, 1/2. Up here, visual, how helpful. Now we've got something closer like 3, 4, 5, depending on the point. So we're going to draw here. These are going to be increasing and above, and then this section right here, it's basically the mirror, except we know all of these slopes are now negative. So the derivative of this one, of f of x using the power rule, is 2x. Last one over here to look at, we got a lot going on. 2 spots, here's a min, here's a max. Those slopes are 0, so we have 2 spots right there at 0. After that, after 1, we can see that this was increasing, so that's going to be above. And here we can see the graph up to that -1 was increasing, so those slopes are above. Between the -1 and the +1, those slopes are decreasing, so those are going to be negative values, and they're going to get graphed below the x-axis. And we can see up here, the derivative would be 3x squared minus 3, which was lovely. All we could really have gone, if I had done a better job making it just a little bit steeper, we would have seen, okay, that slope right there is not just 1.5, but a -3. So really, it comes down like that. So now just some nice things to keep in mind here. So when the first derivative is greater than 0, the first derivative is positive, we can say that we know the f of x graph was increasing. When that first derivative is less than 0 or negative below the x-axis, then we're going to know that the original graph was decreasing. Then the other cool thing we can figure out is if the original graph was concave up, we know that the derivative is increasing. And if the original is concave down, we know that f prime is decreasing. So here's a great graph for you to try. Go through my suggestion, find where the slope is 0 first, and then work the sections, decide if they're positive or negative. Pause this video. And here's a sketch of what your graph should look like. Have a great night.